Okay, hi guys. Our next lesson is on density. So far we learned that density is an example of a physical property, and more specifically, it is a quantitative physical property. So it's describing a substance using numbers. Okay, so before we get into specifics of density, I'm just going to go over a couple terms. So here we have mass. What is mass? The amount of matter in a substance versus weight, which is the force of gravity acting on an object. So what I want you to understand is mass of a substance never changes. Mass is the amount of matter in a substance, those particles we know make up matter, and this is something that a substance or an object carries with it wherever it goes, no matter what. So a mass doesn't change. Whereas weight is something that can change based off of gravity and where you are located or where an object or a substance is located. So weight could change if you were on a different planet. Okay, so mass stays the same, whereas weight can change. Volume is the amount of 3D space an object takes up. Okay, so volume is the amount of space object or a substance takes up. Okay, characteristic physical properties that are unique to substances and therefore can be used to identify that substance, like a fingerprint. So I remember back when we were talking physical properties, we were talking about how specific substances have specific unique properties, like melting point or boiling point. Those are very specific for a substance. So density is also one of these examples. So depending on the substance, the density is very unique to that substance. It doesn't change. Okay, so what is density? It is the amount of matter, which is mass, of a substance per unit volume of that substance. It is commonly referred to as a substance being heavier or lighter. So when we talked density, when we were talking about physical properties, we said the more dense, the heavier, the less dense, the lighter. So density for water is very specific. Again, this is a unique property. The density of water is 1 gram per milliliter. Okay, 1 gram per milliliter. So the gram per milliliter is an example of units for density. Okay, depending on if a substance is a solid or liquid, this can change, but it's always mass per volume. So you'll notice grams is a unit describing mass, and milliliters is a unit for volume. Okay, so it's always units in mass per volume. So grams per milliliter would be describing a liquid, okay, because liquids, we use volume like milliliters, liters. If it was a solid, then it could be something like grams per centimeters cubed or meters cubed, millimeters cubed. So depending on if it's a solid or a liquid, that changes the units, but the units still stay as mass per volume. Okay? Okay, so density triangle. We are going to learn how to calculate the density of different substances based off mass and volume. Or sometimes maybe you're given the density and the volume of a specific substance and you need to determine the mass. So we're going to be using this triangle to help us with our calculations. So it says the triangle is used to calculate unknown variables. So the first thing you want to do is hide the unknown variable. So if you have a question that's asking you to determine what the density is, it means hide the D. So you could just take your hand, you could cover up the D. So I'm just gonna use this Okay, this is me covering it up. Okay, so if I want to find density, I've covered it up, and then the remaining two variables create the equation. So you'll notice that we have mass and volume left. And this line right here, guys, represents division. Okay, this line down here represents multiplication. So in this case, we're left with mass over, okay, we have this division line, volume. So in order to come up with the equation for calculating what the unknown density is, that would look like density equals mass divided by volume. Okay, so remember that divided by line helps us. Okay, I'm just going to get rid of that now. Okay, so we have M, which is mass, measured in grams. Okay, that's the unit, grams. V for volume. If it's solids, like I mentioned earlier, centimeters cubed. Liquids would be milliliters. So you know if you got a density that was in grams per milliliter, it would be for a liquid substance. If you got a volume in grams per centimeters cubed, it would be the density for a solid. Okay, so density is mass per volume. So grams is mass per volume, centimeters cubed. Solids, and then in liquids, mass is grams per volume in milliliters for liquids. Okay, and then just to kind of put things into perspective, 1 milliliter is equal to 1 centimeter cubed. Okay, I just want to do this example one more time. So if we wanted to figure out the unknown variable being m, so if m, mass, is what we were trying to figure out, then you would hide the m, and then what are you left with? It's the d and the v, but the d and the v are side by side. Okay, so that's to indicate using the multiplication. Okay, this line, side by side, is multiplication. So the formula for mass would be m equals, and then what's left over? Density times volume. Okay, so I will again get rid of that. And then lastly, might as well just do the last one. So if we wanted to figure out, if we wanted to figure out volume, you would cover it up, so get rid of it. What are we left with? Mass over, okay, right, that's their division line, density. So lastly, volume would be equal to mass divided by density. Okay, that's how we come up with our equations. I'll get rid of that. Okay. So when doing these calculations, when calculating density for a specific substance, you want to use this method called DESCA. So DESCA stands for data. So D is data, E is equation, S is substitution, C is calculation, and A is answer. So what is data? This means write down everything that was given to you in the question. Okay, so if you were given data and density and mass, write down what was given to you and determine what it is that you need to solve for. If you were given mass and density, that means you're solving for volume, so you need to then come up with the equation for volume. Substitution means substituting what you do know into the equation, so that you would then substitute the mass and the density into the equation to determine the volume. You would then carry out the calculation to get the solution, and then you would write your final answer in sentence form. So if in this case you were trying to figure out volume, you would say something along the lines of, therefore the volume of this substance is blank milliliters, or blank centimeters cubed if it was a solid. Okay, so now we're going to look at a couple examples together. So please try not to look down below too much. Try to stay with me for each step, because I know it could look a little bit confusing or overwhelming when the entire solution is already written out. So just stay with me step by step by step, and hopefully that helps to get to a solution. So it says here, a woman is offered a priceless antique pure gold ring. She wants to know if it is actually pure gold. The ring has a mass of 24.125 grams, so I'm going to highlight that, mass, and it displaces a volume of 1.25 milliliters of water when placed into a graduated cylinder. What is the density of the ring? Is this a pure ring? So remember, substances have specific unique properties, density being one of them. So if it is pure gold, we will know if our answer is the same as the density of pure gold. So we're going to use DESCA to answer this question. So remember, D means data. So let's stick with the D, don't look further down. D is writing down what you have. So in this case, we have mass and we have volume given to us in the equation. So we're going to write those two values down, and we're going to state that it is density that we're trying to determine. E for equation means come up with the equation for density. So keeping in mind, you're going to use your triangle. You're going to cover up the unknown variable, so you would be covering up the D, and you would be using the variables that are left over to make the equation. So density is mass divided by volume. Okay, so sorry guys, I'm just going to rewrite this here. So density for E, it's easier to see it this way. Density equals mass divided by volume. Okay, so keep in mind, this is your triangle, D, M, oops, V. Okay, so remember, this line means division, this means multiplication. So our equation is density equals mass times volume. So I'm actually just going to cover this up here. I don't want this to confuse you. Okay, so we have our equation. S is to substitute into the equation. So we're going to substitute our known value. So we know mass is 24.125 grams. Keep your units. And we know volume is 1.25 milliliters. So please don't let it confuse you the way that it's represented here. If I was to rewrite this out, it would look like this. D equals mass is 24.125 grams all over volume, which is 1.25 milliliters. If you were to calculate this, you plug this into your calculator, you should get 19.3 grams per milliliter. Okay, so I'll highlight our answer there. Calculation gives us 19.3 grams per milliliter. When calculating the density, remember, it's mass per volume. So we keep the grams per milliliter. Lastly, we have our answer here, which is, therefore, remember putting it into sentence form, the density of the gold ring is 19.3 grams per milliliter. So again, we need to determine if this density was, if this ring was pure gold. And it says here, the density of pure gold is 19.3 grams per milliliter. Okay, so you would be able to look this up. You would be able to look up what is the density of pure gold. Okay, and since 1 milliliter equals 1 centimeter cubed, we learned that on the last slide, they're equivalent. The pure gold ring is actually pure gold. We got a calculation, an answer that matches the density of pure gold. Okay, we'll do another example. It says here, liquid bromine has a density of 3.12 grams per liter. So density of 3.12 grams per liter. What is the mass of 0.250 liters of bromine? So this wording is a little bit more difficult. We're going to start with our data. We're going to write down what we have. So we know we have density. So they gave us D equals 3.12 grams per liter. Okay, now it says what is the mass? So right away, that should remind you, well, we don't know what the mass is. The question's asking me to figure it out. So that's why mass is a question mark, which means that this leftover value, 0.250 liters, must be the volume. And also, we know volume is measured in liters or milliliters. So that must be the volume. If it said grams there or kilograms, then that would be mass, but the unit of liters is also telling us that it's volume. Okay, so we have density and volume. We need to figure out mass. So again, if you were to go and draw your triangle here, okay, this is why this is very important. Density, mass, volume. We're trying to figure out the mass, so we cover up mass. And what's left over? M equals D times V. So density times volume. So that is our equation. Mass equals density times volume. Substitution, we have to sub in our values. So we know that our density is 3.12 and our volume is 0.250. So we're going to sub those into the equation. Okay, these brackets here, guys, don't let that confuse you. It's just like saying multiplication. Okay, so it would be the same thing as me putting here mass equals 3.12 grams per milliliter times 0.250 liters. Sorry, I'm getting into the triangle there, which gives us an answer of 0.78 grams. So we substitute, we calculated, we put that into our calculator, and we got an answer of 0.78 grams. Now you might be wondering, well, how do we get grams as the unit? So you have to remember that we're trying to calculate mass, and grams in this case is going to be the unit for mass. So, sorry, real quick here, I put grams per milliliter here. That should say, my apologies, guys, that should say grams per liter, okay, because that's what we see as our density units. And so another trick here is to cross out the doubles or the unit you have two of. So we have grams once, liters twice. So because we have liters twice, you can go and cross those out, and whatever unit you're left with is always going to be the unit of your answer. So in this case, we cross out the L's for liters, and we're left with this grams. So that is also kind of like a trick to helping you to determine what units your answer is going to be. So mass is measured in grams here. Lastly, you are going to write your answer in sentence form. So therefore, the mass of 0.25 liters of bromine is going to be 0.78 grams. Okay. Okay, if you're having troubles with doing these calculations, please make sure you're reaching out for extra help. During our review lesson, we will definitely do a few more. Okay, so you have a little bit of homework in your booklet, a little bit of practice on pages 13 and 14.